Welcome to today's video on direct proportion. This is the first of 3 lessons on direct and inverse proportion, which is a GCSE, a bit of a niche question. It's got a particular way of solving it, but once we've mastered the technique, it's basically guaranteed 4 or 5 marks for us. So this is a skill that we want to master. What we're looking at is where we've got 2 quantities, A and B, and we say A is directly proportional to B. Now it could be that B, it could be B squared, or it could be B cubed. So we'll give it the general relationship that A is proportional to B to the power n. But you've got to look at the question, and the question will tell you which form of the relationship to use. So you're going to need to take some notes. So please get your pen and paper ready. And when you need to write something down, just pause the video and then you can continue once you've done that. These are the graphs showing direct and inverse proportion. If something's proportional, then as x gets bigger, y gets bigger. And you'll notice that the graph will always go through the origin. Where if it's inversely proportional, as x gets bigger, y gets smaller. But equally, when x gets small, y tends to get very big. And you'll notice that this does not go anywhere near the origin. This is the definition of direct proportion. So if you want to write it down, pause the video and then continue. An example. If you paid £20 an hour, is proportional, what you earn is directly proportional to how many hours you work. So if you work 2 hours, you get 40. If you work 3 hours, you get 60, etc. Now, there's a little trick to these questions. It's definitely a formulistic type question, because the question will say A is proportional to B, or you'll say A is directly proportional to the square of B or the cube of B or whatever. So what we do is we rewrite that as, rather than using the proportion sign, we swap the proportion sign for an equals K, where K is a constant. And what will happen is, in the first part of the question, you've got to find K. Then the second part of the question, what it'll do is it'll give you A, and you've got to find what B is. And you can do that once you know what K is. So it's basically find K, use K. So it's very much a bit of a niche old question. But once you've mastered the technique, we think it's relatively straightforward. Now, to help us do this, we're going to use a magic triangle because we like putting numbers in a magic triangle. Now, at school, they might basically say, right, there's an equation, let's substitute some numbers in it. And the basic skill we're using here is substitution. And whether it's into the equation or whether it's into the triangle, we're basically doing the same thing. But you'll notice in the triangle that A is up the top. So A is K times B. Could be B squared or whatever, but equally B is A divided by K. And what you'll find is the question, first of all, you've got to find K, then quite often it will tell you what B is and you've got to find A, and then it'll tell you what A is and you've got to find B. And they don't deviate much, so we like these because you don't have to interpret them much, you just have to remember, let's get this magic triangle out and use it. So I'd write this down. So pause the video if you haven't done that, write it down and then continue. Let's see how we use it now. So to find K, we must be given A and B. So in every question, it'll say what they are. So the question might say A is directly proportional to B. And so in this case, N is 1. And then it will say when A is 10, B is 2. So if the question's like this, we can just put 2 and 10 in our magic triangle and find K. Once we found K, we can then come up with a formula and say, well, look, A equals 5 times B. Let's show you another example of that. So the question might say A is directly proportional to B squared. And I'll move that up, and then it will say when A is 40, B is 2. Find a formula linking A and B. And what we do is we put 40 into where A is, but then we've got to remember it's B squared, so we have to square 2 to give us 4. So 4 goes down the bottom, 40 at the top. K is just 40 divided by 4. So A is proportional to B squared. We can write as A equals 10B squared. So now we're going to give you just a few questions where what we want you to do is find K. We'll worry about the harder questions later. If you can't find K, you can't do this question. So let's see if you can find K in the next 2 examples. So once I show you them, take a note of them, pause them, then we'll check the answers. So here we want to find K, and the question is going to say A is directly proportional to B, and then we're saying, well, in this case, when A is 33, B is 3. And what I want you to do is find a formula linking the two. And I've drawn the magic triangles there to help you. So you pause, see if you can do it, and then just check your answer. Right, so what we do here is, because it's directly proportional to B, we don't need to do anything to the 3. We can just put the 3 down there on the bottom right-hand corner. 33 goes at the top, so K is 11. So what we can say our formula is A is 11B. Next question again, write this down, pause the video, and then check your answer. This one, slightly harder, we're saying A is directly proportional to B squared. But then it tells us when A is 128, B is 2. And what we want is a formula linking A and B. So we've got to find K. So pause the video, have a go, and then check your answer. So A is 128. We can put that at the top of the triangle. But we need B squared at the bottom. So 2 squared is 4. So we put 4 at the bottom. So then we can find K. And then once we've found K, we can write, okay, K is 32. So we now know that A equals 32B squared. I hope you got that right. And I hope you're beginning to see the pattern. What we now want you to do is check out the video on inverse proportion, which is remarkably similar to what we've done here. And then after that, look at the video where we've got a selection of exam questions for you to tackle. Thank you for listening.